Let's go on to our next example. Again, we are working with partial sums. We're asked to find the first four partial sums and then the nth partial sum for this sequence formula, AN. Okay, so let's get ready to start and calculate the first four partial sums. Okay, so let's look at first S1. Okay, so if we look at S1, okay, so if n is 1, we're going to have 1 over 2 minus 1 over 3. Getting a common denominator of 6, that's going to be 3 minus 1, 3 minus 2, which is 1. 1/6, and I'm backing up. Yes, we were right. 1/6 would be the first partial sum, and here we found A1. Okay, the second partial sum, remember, is A1, 1/2 minus 1/3, plus A2. Okay, so we have to figure out now what A2 is. So we're going to plug in 2 for n. If I plug in 2 for n, we get 1/3 for the first fraction. Plugging in 2 for n, we get 1/4 for the second fraction. And what we notice is that these cancel out, so all we really are calculating is 1/2 minus 1/4. That's going to be a common denominator of 4. So if I multiply this by 2 over 2, 2 minus 1 would give us a fourth for the second partial sum. Okay, so let's look at S3. S3 is going to be A1 plus A2 plus, now we've got to figure out what A3 is. Okay, so we're going to plug in 3 for n, so we get 1/4. We're going to plug in 3 for n, so we're going to get 1/5. We see that these cancel out, making our work a little bit easier. We're going to take 1/2 and we're going to subtract 1/5. Now that's going to be a common denominator of 10, so 5 over 5 minus 2 over 2 will make this a 2 over 2. So 5 minus 2 is going to give us a 3 over 2. Okay, so we have one more partial sum. That's going to be S4. Okay, so for S4, we have 1/2 minus 1/3. Okay, so all we're going to do is we're going to add in A4. Okay, so A4, we would have a 1/5 here. Okay, so let's put in our A4. If n is equal to 4, 4 plus 1 is 5. So we've got 1/5 here. 4 plus 2 would be 6, so I'd have a minus 1/6 here. We have all those middle things canceling out like we had up here. And so here would be just looking at 1/2 minus 1/6. Common denominator is going to be that 6. So here we'd multiply by 3 over 3. 3 minus 1 would give us 2 over 6, which is 1/3. And so there are our 4 partial sums. Okay, now it wants us to find the nth partial sum. Is there a formula that I can use to work with all of these? Let's see if there is. Okay, so S1 was 1/6. S2 was 1/4. So 1/4 is also 2 over 8. This would be 3 over 10. This is going to be 4 over 12. See how I'm not wanting to write the reduced fraction because I want to figure out a pattern. If this is 1/6, 2/8, 3/10, and 4/12, the next one would be, what would we guess? 5 over 14. Okay, so we can actually get a formula for Sn in general. Up top, n is 1, 2, 3, 4, which we know is the domain. And then on the bottom, let's see, we've got, if n is 1, we've got 6. If n is 2, we have 8. Make just a little bit of notation so we can kind of see if we could get that bottom pattern. Okay, so what if we did, let's see, so here we would multiply by 4 to get 8. We're trying to think about this pattern. So let's see, let's try this. Okay, so we see that these are all even, and a way to generate even numbers is 2n. Let's see how that works. Let's say n is 1, we get 2. If n is 2, we get 4. If n is 3, we get 6. If n is 4, we get 8. So this generates 2, 4, 6, 8, 10. We need to start that at 6. Okay, so what if we said 2n to generate the even, but that gives us 2 and we need to be at 6. So we're going to add 4 to that. Okay, so if n is 3, 6 plus 4 is 10. If n is 4, that would be 8 plus 4 is 12. And so now I think that we have our denominator. And there's the sum of the nth partial sequence.